Hi everybody, my name is Jonathan Fima. I'm a PhD student at the M Lab, and today I will make you a small tutorial about how to use our new version of the Lirot.ai app. So basically, let's see what you need to set up to start to work with the app. So you can find it in the App Store and download it. Second, what we recommend is before you use the app is to charge your device in order to have the maximum power you can use from it. Third is to close everything that is currently open in your iPad. And lastly, go to the settings, go to battery, and be sure that low power mode is off. And go to display and brightness, auto lock, and select never. Now we are ready to go to the Lirot.ai app. First thing the app will ask you is to connect. So if you already have credentials for the app, you can use them. Or if you don't have some, we can just create a new account right now. So we need a full name. We collect some information about the user to know who is using the app and how we can improve it for the future release. So I'm Jonathan Fima. I'm a student at the Technion. I will put an email. And a Jimmy password. So I click on register, and the first thing you will see is the term of use of the app. So we recommend you to read them. And once you are fine with them, you can click on any button on the menu. So I will click on the home button, for instance, and it will show you a pop-up saying if you agree with the term of use or not. So if you agree with them, just click on agree, and it will switch to the home button. So what you have here is a presentation of the app. So you have a small presentation, some contact information, and also where you can find the different research papers that was basing the different modules of the app. So then we have a new analysis menu. Also be aware that every time you see this pop-up that asks you something, you can just quit it clicking outside of it. For the new analysis menu option, we need a name, so it will ask you whatever you try to do, it will pack this pop-up, but in other moments of the app, you can just close this pop-up like this. After, we have the previous analysis menu, so me, I have a trash folder, don't focus on it, you should be empty at the beginning of the app. And after, you have an account folder. In the account folder, you have access to the email address of the account, you can log out, you can back to the term of use if you click on it, and you can delete your account in case you don't want to collaborate with us anymore. So now let's see one last thing that the app install. So you can go to the Files app of your iPad, go on my iPad, and now you will see a Lirot.ai folder. So if you click on Lirot.ai, you will have an example folder which contains some retinal images example that we download with the app. Basically, you can see the naming of the retinal images. So DR1 for diabetic retinopathy stage 1, DR2 for diabetic retinopathy stage 2, stage 3 and stage 4. So we have one example for each of those stages. You have one discentered images of low resolution, non-discentered images, of low resolution. You have one non-discentered images with high resolution and 30 degrees of field of view. We have one ultra-wide image, and we have one disc-centered images with 30 degrees of FOV. So now let's create a new analysis. So let's call it test video demo, for instance. I click on confirm. And after I have access to the different modules that are within the analysis. So we can either use the segmentation, which allow you to segment automatically the optic disc, the optic cup, and the blood vessel within the retinal fundus images. We can add the vasculature biomarker, which computes some feature based on the previous segmentation. And when you select this module, you see that you have an additional input from the user that is required, which is if you want to use a fixed sized region of interest of the optic disc. So basically, all our images for these two modules are processed with a 1444 by 1444 image size. And we can compute the vasculature biomarker either on the full image, either on a fixed size of 500 pixel radius region of interest. So if you want more information about this region of interest, we recommend you to go to read our research paper that are in the home menu. But for now, we will just enable this option. Lastly, we can also add the diabetic retinopathy button. Option, that allow you to perform some staging of the severity of the diabetic retinopathy condition of the patient. And also for this module, we have an additional user input, which is if you want to compute some extra visualization. So this extra visualization are really nice. They show you what the model focus on at the moment you do the prediction and some lesions that can impact the diabetic retinopathy stage of the patient. But be aware that this takes a significant amount of time and RAM requirements. So if you don't need them, it will go faster if you not activate this button, but for the purpose of the tutorial, we will activate it. Also be aware that you can select each of the modules independently, a single one of them or all of them. And be aware also that if you click on vasculature biomarker, it will automatically enable the segmentation because it's needed to perform its inference. While if you remove the segmentation, it will automatically remove the vasculature biomarker. Again, for the purpose of this tutorial, we will select everything. So once everything is selected, we can select a folder to analyze. So here we need to go to a folder of image. So let's go to our example folder on my iPad, Lirot.ai, examples. And what we need is not to select an image, but a folder of image. So the folder we want to select is the example folder. So once we are inside, we can just click on open. Here you will see that the folder is loaded within the app, and we will select the image we want to analyze for this tutorial. So let's say we want the diabetic retinopathy stage 3 and the discentered 30 FOV. Click on done, and you can click on start. Starting from now, we just recommend to let the iPad do the job, go to take a coffee, and back when it's ready. So each of the image will be processed in 10 seconds per module. So 10 seconds for diabetic retinopathy, 10 seconds for the vasculature biomarker. Of course, this is an average. It can go slower or faster depending on the module itself and the device you have. And of course, depending on the fact that you want visualization or not for the diabetic retinopathy module, it can go faster or slower. So you see that, and one last thing also is the estimated time that you see here is based on the previous iteration. So the more big is your analysis, the more image it contains, the more this number will be accurate. So let's give it a few more seconds to finish the vasculature biomarker. And when this is done, we can go to see what our result of our analysis. Okay, so now the analysis is finished and you see that new analysis button appear. Until we click on this new analysis button, the app will be considered of having one analysis running. I will explain you why it's important after. But for now, we will keep it like this. We will not click on new analysis and we will directly go to the previous analysis to see our result. So we see first in previous analysis that we have the name of the test video demo that we have created. And when we click on it, we have the diabetic retinopathy stage 3 CDIR on the distenter images that we selected. So let's pick the first images first. We see that it has loaded with its segmentation because we was having selected the segmentation modules. And that we have 3 menus now. The view CSV data, the segmentation studio, and the explainability. So let's start with the first one. The view CSV data got one switch show analysis and one export button. When you click on show analysis, you will see the name of the analysis and all the the name of the image, and all the metadata that was computed for this image. So here the diabetic retinopathy score that the model have computed. So 2.7 when the reality was 3, it means something really far. The disk feature. So where is the position of the disk, what is the radius of the disk, what is the size at which we process the image, and what is the size of the region of interest if you were selecting region of interest to be yes. If you don't want region of interest, this would be -1 that you can keep track of your experiments. We have also some geometrical biomarker both for the arterial and for the veins. We have also some central retinal equivalent biomarker both for the artery and for the veins. And we have also the fractal vascular biomarker, both from the artery and from the vein. Be aware that one of the interesting numbers that is here is the number of vessels that was detected for the central retinal equivalent analysis, which is not a common biomarker, but is something that we provide as information to see how much blood vessel was used to compute the Knudsen and the Hubbard formulas. Now, the second button is the export button. When clicking on it, you have the ability to export the analysis using any app that your iPad have access to, or your Mac. So you can send it by mail, by message, by Slack. For the purpose of the tutorial, let's save it just to the file on my iPad, and let's click on save. So let's see where it is now. We can just go to files on my iPad, and we have the test video demo CSV. And you can see that we have the analysis for each of the image of the analysis, and we have all the features that have been computed that you can export for further use. Now let's open the segmentation studio. So these have everything that you need to modify the segmentation. By segmentation, I mean the blood vessels, the optic disc, and the optic cup. First, we have a cancel button. When you click on it, you will back to your previous to your list of previous analysis, except if there is something that have been modified in the image. Let's say now I will modify it, and after I will show you how you can do. With my Apple Pencil, I'll just do something, and I click on cancel. It will ask you to confirm before you quit. This is just a security in case you click on cancel by mistake, but you don't want to, in case you just want to continue to work. So here, let's say that it was really by not by mistake, and I want to cancel what I have changed. So you can click on cancel, and you will back without any modification. We have also a save button. So let's say now I'm happy with this current segmentation. I don't want to edit it. I'm fine with what it is right now. I can click on save, type yes, confirm. And next time I will open my image folder, I will see that this one is in blue. It means it have already been checked by someone, and someone is happy by what is the current segmentation in this image. After, let's see how we can modify it. So we have few options. We have the pencil size. That will be how much big will be your pencil. Here it's 1 pixel width, 2 pixel width, 3 pixel width, etc. We have also the pencil button here that tell you if you are writing or erasing. When the pencil is this, like this, it's writing, and when it's reversed, it's erasing. Lastly, you can decide what you want to work on. If it's for the artery in red, the vein in blue, the optic disc in pink, or the optic cup in yellow. And after, you have some transparency stuff that help you to better visualize what you need to work on by modifying the transparency. Finally, you can click on this to have more contrast. So let's say that we will modify the segmentation for the next image, and for now we are fine with the segmentation studio. The last thing we have is, because we was performing a diabetic retinopathy experience with explainability, so we have some explainability that are loaded. Be aware that with this version of the app, the DRIT map and the lesion segmentation button will always be here, but if you was not performing explainability experiments, you will not be able to see what is their outcome. Like, it will not display anything. But here we can see what the model was focusing on, and we see that it's focused on maybe on the lesion. And if we want to be sure that those are the lesions, we can directly display the lesion segmentation. And we see that the heat map of the model highly overlaid with the lesions that our segmentation model have found. Okay, so now let's go to the next image, cancel. Let's go to this center 30 FOV, and let's say we want to play a little bit with the segmentation studio. So let's just bring back everything. Perfect. And let's say there is some segmentation I want to modify. So let's say this blue here. So I select the blue. I want to remove this. That should not be here. Also, this one was misleading. I want to correct this one. And because it's a small vessel, I will choose a pencil size. Maybe 1 is too small. Let's take 2. 2 is perfect. Okay. Let's remove this and this. Let's correct all the minor details that remain to be corrected. Here, and here, and here, and here. We can also, of course, correct the disc and the cup, but me, I'm satisfied with the current version of the segmentation, so I can just click on save and type yes. I can confirm. So now that all the images have been corrected, the name of the experiment should be in blue. To see it in blue, you just need to reload the page. So click on previous analysis again, and now it will become blue. What it means that it's blue, it means someone has checked all the segmentation and is fine with all the segmentation. So we can now process a recomputation of the biomarker because we have corrected everything and the biomarker based only on the segmentation. So we can do this, recompute biomarker, just scroll it to the right. Unfortunately, we are not able to process several experiments in parallel because our iPad have a limited amount of RAM. If you want to do this scroll on Mac, you just put 2 fingers on the trackpad and slide them to the right. So in order to be able to run a new experiment, we need to freeze the previous one. So we just need to click on new analysis, and then we find. We can come back, do our scroll, and now they will ask us if you want to use a fixed size region of interest. To be comparable to our previous computation of biomarker, we will say yes, of course. Okay, and if we want to see what is the current analysis, we can back to the analysis button, and you will see that now a biomarker analysis is running without the segmentation, which means it's using the previous segmentation we was having in our app. Perfect. So let's go back to our previous analysis and let's see our disk-centered, for instance. We can go to the view CSV data, show analysis, and we see that now for each of the features, we have the original version and the corrected version. Of course, there is not a big changes because I really change a minor amount of pixels here. But if you have a segmentation that you have heavily modified, you will be able to observe those differences and to have a corrected version of the biomarker. Let's see what's happened now when we export them. Save to file, on my iPad, replace the previous one. Let's open it again. You see again that here you have the original version and the corrected version for each of the biomarker. The final thing we can see now, it's still in the file app of the iPad. When you click on it, you can go to the Lirot.ai and you will see that there is a new folder for each of the experiments. So we can click on our experiment, the test video demo. We will see a lot of CSV, which are the CSVs that are the ones that constitute the full big CSV that we exported before, so the fractal analysis, the central retinal equivalent, the geometrical biomarker, the disk feature for the arteries and for the veins. But we also have some folders. And if we look what are these folders, we can see the zone ABC, which are the different zones on which we have computed the central retinal equivalent, according to their formulas. We can also see the ROE, the region of interest. So this is the fixed size region of interest that was used to compute the biomarker. Of course, sometimes it goes out of the image, and this is something that you will need to analyze if the circle is not perfect. After we have the processed images, where we have the two images after they have been pre-processed, which means just before we fed them to the deep learning model. We have the ODC, so the optic disc and cup segmentation that you can export. We have the segmentation folder itself, which contains your final segmentation with the modification you have manually made. We have the diabetic retinopathy processed image, which is mainly roughly the same image as the other one, but with another resolution, because the diabetic retinopathy module has another resolution than the segmentation module. We have the segmentation of the diabetic retinopathy, so the lesion mainly. And we have the heat map of the diabetic retinopathy module, where it was focusing on. So now you have access to all this information. You can create your personal segmentation, export them, do whatever you want with them. You have access to the biomarker, and that's it. So we wish you like a good usage of the app, and thank you for listening.